Hello and welcome back. And today we'll be talking about trigonometric functions through the uses of the 30, 60, 90 right triangle and also through the 45, 45, 90 right triangle. Finding the exact values using these trigonometric functions, we will be successful into evaluating this block of instructions. Now, first of all, we want to talk about the equilateral triangle and how it was derived, or how the 30, 60, 90 triangle, right triangle was derived from this equilateral triangle. Mathematicians and scientists had toiled through making these great discoveries for us to do what we need to do today as mathematicians and engineers. However, let's look at the equilateral triangle with the length here, see, of 2 here, 2 here, and 2 here. Now, that's what makes it equilateral, because the sizes on all 3 of the sizes are the same. Now, if you see this now, when you draw a perpendicular bisector down the middle here, this actually divides the triangle in half, making this 30 degrees here and making this 30 degrees here respectively. And going down here and also dividing the side in half, which was, this side was actually 2 units, but now it's going to be 1 unit on this side and 1 unit on this side. Thus making it a 30, 60, 90 right triangle. They took a piece of this, of course, and we need to evaluate our trigonometric functions through this. Now, one leg is a unit of 1, and of course the hypotenuse being alongside is 2 units, but we have to find the other leg here. And so we'll find the other leg by using the Pythagorean Theorem. And so we'll plug these values in to A and also into C, and isolating B squared, because we must solve a B. So we take -1 to both sides, and we bring down the b squared, and we subtract, so 4 minus 1 will equal to 3. So b squared is equal to 3. So we're not quite done yet, because we have to solve for b. So b is going to equal to the square root of 3. So now we have all of our sides. So now we can start evaluating using the triangle here, and using the trigonometric functions, which here are co-functions of one another, and also complementary angles. So when we establish this and evaluate each of these functions, we're going to come up with the same value. Amazing. So let's just look at using the triangle, and if we have pi over 6, which is equal to 30 degrees, and pi over 3, which is equal to 60 degrees, in which these angles are complementary to each other. Find the exact values using 6 trigonometric functions, right, which are called functions of each other. So let's look at this here. Let's look at sine pi over 6, which is equal to sine 30, and it is the opposite over the hypotenuse. So we're looking at the angle here, 30. So if this is opposite over hypotenuse, opposite side in this case will be 1, and of course the hypotenuse will be 2, so it'll be 1/2. So that value will be 1/2. And so we go over here to cosine. Cosine will be now pi over 3, which is equal to 60 degrees, and it's the adjacent side over the hypotenuse. Now again, so we're looking at this angle here, 60, and it's the adjacent side, so that means that this side is right next to the angle. And so it is, again, the same value, 1, right, adjacent side, 1 divided by 2. Let's go here with cosine being pi over 6, and also sine being pi over 3. So cosine pi over 6 is equal to the cosine of 30 degrees, and of course, cosine is the adjacent side over the hypotenuse side. So in this case here, we're looking at this here, we're looking at the 30 here, So it's the adjacent. So this side is right next to the angle. So, and then of course we have the hypotenuse, which is 2. So it's going to be the square root of 3 divided by 2. Let's look at sine pi over 3, which is sine 60 degrees. So we're looking at this angle here, and it's the opposite side over the hypotenuse, which this is the opposite side to here. And so here this will be the square root of 3 over 2. So basically you have tan, cotangent, cosecant, secant, and of course a repeat of these things using each other's complementary angles, and they are co-functions of one another. So it's the same concept in which you'll evaluate the triangle and plug in the values and solve for them. If you have any questions, we will continue to have questions, and you need me to break anything down or solve anything mathematically that you might be stuck with, stop the video, rewind, repeat some things, try to take notes, and see if you can work through it. If not, we will go over some of these problems in class. I'll be glad to help you with anything that you are having problems with. Now, let's go to the 45-45. It's basically the same concept, except here, the 45-45-90 right triangle is an isosceles triangle. Do you know why it's an isosceles triangle? Do you remember your geometry from a long time ago? Well, an isosceles triangle has two sides which are what? Congruent, if you will. And of course the angles are 45-45 and 90. And with here, we have to find out what C is. We have to find out what the hypotenuse is. So if you will, come follow me, and we'll do a little bit of work over here on the 45-45-90 right triangle. And of course, to find the side that you need to find that's unknown, you need to use the Pythagorean Theorem. A squared plus b squared is equal to c squared. Taking a squared, putting the value 1 in, plus 1, well, 1 squared plus 1 squared is equal to c squared in this case. So you're going to have 1 plus 1 is equal to c squared, which that means is 2 is equal to c squared. So the variable is isolated, so you're going to have to solve for c, right? Solve for c. So when you solve for c, c will be the square root of 2. Now, of course, again, you're going to use the same concept as we use the 30, 60, 90 right triangle, using the co-functions and the complementary angles to solve the problem. So, of course, let's just do, we'll do 1 or 2 here. Sine pi over 4, which is the sine of 45 degrees. And of course, with the sine is the opposite side over the hypotenuse. And with that, you see that 1 divided by 1, the opposite side divided by square root of 2. And when we rationalize the denominator, right, because it has a radical in the denominator, you have to simplify it. And we multiply the square root of 2 to the numerator, and to the denominator, of course, we get an answer of what? The square root of 2 over 2. Now, let's talk about cosine pi over 4, which is the cosine of 45 degrees. And that's the adjacent over the hypotenuse, and that's also 1 over the square root of 2. Rationalizing the denominator and simplify it will give you the same values, the square root of 2 over 2. Now, you have your trigonometric functions here, and the co-functions with the complementary angles, so it's the same concept. Same procedures you would do to find these exact values, okay? So let's look at the chart. The chart here is the setup from all the calculations that we've done. However, there's no need to memorize the chart. It's always great to know how to do the calculations and stuff, because applications for engineering, a good example, truss analysis is a good mathematical application, a great problem-solving problem in which trigonometric functions are used to solve truss analysis to find the loads, compressive strengths and tensile strengths of the beam or the truss members. It's amazing how this block of instructions can solve many problems in the world today. So this concludes the video, and I've enjoyed it. So we have more to come. We're going to be talking about eye levels when we're actually looking at something from a distance. We're going to see the eye levels and the elevation of depression. And what we'll do, we'll learn how to calculate tan now on this next one. And when we calculate tan, we have to calculate either the distance from one part to another or the height from the eye level. Well, we'll see you next time, and I'm looking forward to seeing you again, and we'll talk about more of trigonometric functions using the tan feature.